All right, my darlings, we've made it to the end, the final problem. This also, like the cone one, is on the longer side, which is why I've got 2 slides to go through it. Let me know what questions you have, because I'm sure there are going to be some. All right, point P is moving along the curve y equals the square root of x. Suppose that x is increasing at a rate of 4 units per second when x equals 3. How fast is the distance between P and the point 2, 0 changing at that instant? All right, lots of information there. First and foremost, I hear this. I've got a point, it's on a curve. Let's draw that curve. Y equals the square root of x, starts at the origin, 0, 0. Then it has the point 1, 1, and then it has the point 4, 2. All right? So that's y equals the square root of x. All right? Okay. Now, the next thing is I've got x is increasing at a rate of 4 units per second. So I know dx dt is equal to 4 units per second. Okay. And it said that it was increasing, so I know it's positive. And we know that it's going to be when x equals 3. But that's a value that's changing, so I can't use that yet. All right? But here's what I am going to do. I'm going to mark that point on the curve just as a frame of reference, okay? But I'm not going to label it just yet. I'm just going to mark when x is 3 we're talking about right there, okay? Now, how fast is the distance? How fast is the distance between the point P, so let's label that point P, sorry, and the point 2, 0. So here's the point 2, 0. Okay, so that's the 2, 0. How fast is this distance changing? I want to know how fast that's changing. All right. So much information. So here's what I'm going to do. I'm going to blow this picture up. All right. I'm going to make it nice and big. So the important thing that I have here is I'm talking distance. So I want to talk about distance formula or Pythagorean theorem as I did before. So the important things. All right. If I just look at that one quadrant. Here we go. Sorry. A little slow on the uptake today. 1, 2, 3, 4. 1, 2, 3. Okay. And I've got my points here, here, and here. There's my function. Here's my point P. Yes, I could figure out the coordinates of that point, but I'm going to leave that blank for a moment, okay? Because keep in mind, that's moving. It's moving side to side. Actually, it's moving from left to right because x is increasing, okay? So that point is moving that way, all right? And then I've got this point down here, and I've got this distance. So I'm going to make this into a right triangle, right, like that. All right, now this distance I know is 2. This bigger distance is the x value I'm focused on. So what's this little distance going to be? All right, so the big distance is x, the little distance is 2. This distance is going to be x minus 2. Okay, so I can use that, x minus 2. And then I've got this. Well, this is just a y value. It's going from 0 up, okay? So this is y, and this is y is equal to the square root of x. So guess what? That coordinate point, yes, I could write that it's 3 square root 3, but I know it's changing. It's the point x square root x, okay? Because whenever I plug in the x value into the function, I'm going to get the square root of x out of it, so the output value, the y value, is the square root of x. All right, where are you going with this, Mauro? Let's try Pythagorean theorem, all right? I want to focus my attention on this triangle right here, okay? So I'm going to call this unknown distance D. Actually, no, let's call it R. Let's give it something other than a D because we have D's in our derivatives and that could get confusing. So let's call it R. So I've got this distance, x minus 2 squared, plus this distance, y squared, equals this distance, r squared, okay? But I can simplify this down to a single variable because this is now x minus 2 squared, but y is the same as the square root of x. And now I want to clean it up as much as possible, all right? I'm sure there are going to be questions on the setup of this, so please do not hesitate to reach out and let me know what questions you have. Alrighty, here we go. Algebra time. Simplifying, I'm going to get x squared minus 4x plus 4 plus the square root of x squared is an x, and that's equal to r squared. So now I'm going to have x squared minus 3x plus 4 equals r squared. Keep in mind, I haven't done any calculus yet. It's all the algebra, pre-algebra, geometry. So now I want to find the derivative of this. All right, I want to differentiate. So the derivative of x squared, is 2x, getting ahead of myself, dx dt. The derivative of 3x is going to be 3 times dx dt. The derivative of 4 is nothing. The derivative of r squared is going to be 2r dr dt. So now from here, I want to solve for dr dt. Okay, we were being told to find dr dt. This is our quantity that we want to solve for. But we were told x, and we were told dx dt. So this isn't going to be so bad. The x value we were told to focus on was 3. The dx dt was a 4. All right. And then we're going to have minus 3. The dx dt is another 4. Equals 2 r. I don't know. I'm going to have to come back to that. Dr dt. So now I just have to figure out my r value. All right, but let's clean this up a little bit. Let's see. I've got 6 times 4 is 24. Take away 12 equals 2 times r dr dt. So the left side is a 12. I can divide out the 2. That's going to give me 6 equals r dr dt. So now I need to go back and figure out, well, what the heck is r? All right. And we can go back and figure that out using this equation right here, because this was the simplified version. So I can just plug in that x equals 3 to that, solve for r, and then I have my number. So I'm going to do that. I'm going to try to squeeze it off to the side here. I'm going to do x squared minus 3x plus 4 equals r squared. Okay. So x is the number 3, so this is 9 minus 9 plus 4 equals r squared. So that's going to give me r equals plus or minus 2. All right, but we're talking about a distance, so it doesn't make sense for it to be negative, so it's going to be r equals 2. So now I'm going to replace that r, boop, gone, with a 2. And that's going to give me dr dt is equal to 3. And that's just going to be in units per, was it per minute? Hold on a second. Nope, per second. Per second, Miss Morrow. Okay. All right. There you have it. Related rates in a nutshell. So much fun. So much work. You got to take your time. You got to be patient. You got to read the questions. You got to think. All right. Let me know what questions